Here is the analog input and NAND gate oscillator, part A and B of this build, made up of one PBNO push button, a yellow LED, two 1 million ohm resistors, one 10k ohm resistor, one 470 ohm resistor, one 10 microfarad capacitor, a 0.1 microfarad signal diode, and a 4011 NAND gate IC, where all four of its NAND gates are used. When the button is pushed for part A, the LED turns off because two lows represent a high, and the LED always has one lead in the positive rail. In contrast, when the button is not pushed, the LED stays on, as two lows make a high, ultimately keeping the LED on. The button is pushed for part B. The NAND gate oscillator creates a clock signal, altering between high and low voltage, causing the LED to flash on and off quickly, oscillating. The third circuit is the decade counter. For this circuit, the second IC chip is introduced, a specialized IC chip called the decade counter IC, giving the circuit its name. The input of this IC chip is the clock signal from the past circuit, whereas its outputs are each wired to a different LED, which ultimately create this pattern. As you can see, the LED on the far right is different. It's called the divide by 10 pin and is high for 0 to 4 and low for 5 to 9. Therefore providing an output of 1 divided by 10 of the clock frequency. The fourth circuit is the decimal counting binary up-down counter. In this circuit, another IC chip is introduced, being the second specialized IC chip, the 4510 binary counter IC chip. To use this IC chip, once again the clock signal is needed and wired through its input pin. Next, its carry-in, C1 pin, is grounded, and finally the up-down pin is wired to the SPDT slide switch, which when flipped allows the circuit to count backwards. Finally, the output pins are each wired to an LED as they represent a different binary digit. Here you can visualize this. The final circuit, part E, is the binary counting decimal decoder, where the final IC chip is introduced, being another specialized IC, the 4511 7-segment display driver IC. In this circuit, the common cathode 7-segment display is introduced, which will be displaying the values in a base 10 form. The 7-segment display is wired to the 4511 IC chip through 7 660 ohm resistors, which match up to the corresponding letters. This can be visualized as shown, and now flipped using the SPDT slide switch introduced in the previous part.